So hi, we will study about Dijkstra algorithm. So Dijkstra algorithm is used to calculate the minimum or the shortest path between the source vertex and the destination vertex. So let us take an example of this graph. In this graph we have path from 0 to 1 and we have also a path from 0 to 2 and 2 to 1. So the distance between 0 to 1 is 2. The weight represents the distance between the given vertices. So the distance between 0 to 1 from this edge is 2. And while we consider the edge 2, the distance between 0 to 2 is 4 and the distance between 2 to 1 is 8. So the total distance between 0 to 1 from this path is 12. So the minimum distance from 0 to 1 is 2. There are various paths from one vertex to other. Like for example, we can say that the distance between 0 to 3 is 9, as there is a direct edge between 0 to 3 with weight 9. If we consider the path 0 to 1 and 1 to 3, so the distance between 0 to 3 will become 2 plus 3, which is 5, which is less than the distance of direct edge between 0 to 3. So we need to consider all the edges and find the minimum distance path from a given vertex to another vertex. So we will use Dijkstra algorithm to calculate the shortest path between the two vertex of a given graph. So it is similar to Prim's algorithm. Firstly, we will initialize the weight of the source vertex. So we will take a source vertex here. We will take 0 as the source vertex and initialize its weight by 0. And rest all the others will have a weight of infinity. Now for each of the following vertex, we will calculate the path such that if the given weight of the neighboring vertex is greater than the sum of the weight of the vertex plus the weight of the edge, then we'll update the weight. So we'll take the example and find the shortest path using Dijkstra algorithm. So here we will maintain three types of parameters. One is nodes. Second one is the distance. And third one, we will check that if it is visited or not. So here are the three parameters that we need to maintain. The nodes are 0, 1, 2 and 3. So we will initialize the weight of the 0th vertex as 0 and rest all the other vertex as infinity. Now we will see the neighboring vertex of 0. So the neighboring vertex of 0 is 1, 3 and 2. So all the remaining three vertex are the neighbor of 0. So we will check. 1 has the weight of infinity, and if we'll check the distance between 0 to 2 plus the weight of the 0th vertex which we are exploring. So the 2 plus 0 becomes 2, which is smaller than infinity. So we'll make an update over the weight of 1. So we'll make an update that is 0 plus 2, which is equal to 2. So the weight of 1 becomes 2. Similarly, we will check for the vertex 3. So at present the vertex 3 has a weight of infinity, and 0 plus the edge weight 9 is less than the weight infinity. So we will make an updation over here 9. Okay, now we'll check for the remaining vertex, which is 2. So 0 plus 4 is less than infinity. So we'll make an updation over the weight of 2. So after traversing the first vertex 0, we updated the weight of each and every vertex as 2, 9 and 4 because they are all less than infinity. So after exploring the 0th vertex, we have this final configuration and we have visited the 0th vertex. Now from the remaining unvisited vertex, we will take the vertex with minimum weight. So the vertex with minimum weight is 1. So we'll explore the first vertex. This vertex is visited. Now we'll explore this vertex. So how many vertex has an edge from 1, 0, 2 and 3. But as we know that 0 is already visited, so we'll visit 2 and 3. Now the weight of 2 is 4 and the distance between 1 and 2 is 8 plus the weight of 2. 8 plus 2 becomes 10. 10 is always greater than 4, so we will not make any updation over here. Now we will check for 1 to 3. So the weight of 3 is 9, but the weight of 1 plus the weight between 1 and 3 becomes 5, so it is always less than 9, so we will make an updation over here. Also here we do not need to take care of the parent vertex, as we are not going to take that, because we are not interested in calculating the parent of the given vertex. We are only interested in calculating the shortest path from a given vertex, so it is 5. So we have explored the first vertex. Now we will move towards the minimum of these two, which is 4. So weight which has minimum value is 4 and the vertex is 2. So we will explore the second vertex. As we know that it has an edge from 0, it has an edge from 1 and it has an edge from 3. But we have already visited 0 and 1. So we will explore it between 2 and 3. So now the weight of 3 is 5 and the distance between 2 and 3 is 6 plus the weight of 2, which is 10. So 10 is greater than 5, so we will not make any updation over here, and rest all the vertices are visited, so we will mark it as visited. So 2 is also visited. Similarly for 3, we can see that we have visited all the remaining vertices and we cannot make any updation over here, so we will mark 3 as visited and we cannot update the weight over here. So at last we will see that for each and every vertex 1, 2, 3 from the source vertex, we have the distance, shortest distance as 2 for the vertex 1, 4 for the vertex 2 and 5 for the vertex 3. So how we can verify it from the graph that the minimum distance from any path of the given graph between 0 and 1 is always 2. You can check it. The minimum distance between 0 to 2 is always 4 from any path of the graph. We can verify it. And the distance between 0 to 3 for any path of the graph is 5, 0 to 1 and 1 to 3. So by this Dijkstra algorithm, we can calculate the shortest distance between the source vertex and the destination vertex in the given graph. Thank you.